Yeah, so my name's Brad Klingenberg. I lead one of the data science teams at StitchFix, a personal styling service for women. And starting this fall for men as well as we launch a men's line, so keep an eye out for that. Today I'm going to be talking about making fashion recommendations with humans in the loop. And I'll share some lessons from StitchFix where we commit to our recommendations by actually physically sending inventory to clients. And the headline from today is that using humans in the loop to make fashion recommendations works really well, but that is complicated. And in particular, I'll share 3 lessons from StitchFix. So the first is that by introducing a layer of human selection, we introduce new feedback loops into the recommendation system. The second is that using human selection can actually change the objective function you use for solving machine learning problems. And the third is that even human stylists need feature selections to make good decisions. But before we get into these lessons, I'll need to tell you a little bit about StitchFix and the way that we use human selection and algorithms to make recommendations for our clients. So as I said, StitchFix is a personal styling service for women. And the way it works in a nutshell is that a client will come to our website, tell us a bit about themselves. So they'll tell us their sizes and style preferences, the amount of money they'd like to spend. We'll then pick 5 things and we'll send them to the client. She gets to keep what she likes and sends back what she doesn't. And the key there is that the client is not actually picking the items that are sent to her. We're picking them on her behalf as a personal stylist. And so you can think about this as literally making a bet on the recommendation that we make for a client. So in a little more detail, our clients tell us a lot of structured information about their preferences. So they're different types of sizes. We have them rate different images of different types of styles. They tell us about different brands that they like, if they like to spend more or less money in different categories. And we take all that information and then we look at our inventory. So much like a traditional retailer, StitchFix buys and holds its own inventory. And so we have a matching problem. So given the request from the client, let's find 5 things that we think she's going to love the most. And so we take all the data that we have about our inventory and all the past feedback that we've collected from previous shipments with clients, and we distill that down into a set of 5 things that are sent to the client. She then gets to try things on at home, has a few days to decide what she likes, sends back what she doesn't. And so this whole process really hinges on being able to predict what a client is really going to want to keep and what will delight the client. And so really the whole process of the business is about optimizing that decision. And we do that with a 2-stage process for recommending inventory. So the first stage is to take all the data that we have. And so broadly speaking, we have 3 categories of data. So we have information about the client that they've told us about themselves when they sign up. We have information about our inventory. So when we buy things, our merchants create structured attributes describing all sorts of different facets of our inventory. And perhaps most interestingly, we have feedback. So whenever we send a shipment to somebody, in addition to providing implicit feedback about their preferences by what they keep and what they don't keep, clients share explicit information about whether something was too big, whether it was too small, if they like the style, if they like the price. We can take all these 3 categories of information and distill them into a set of algorithmic recommendations. This set of recommendations is then curated by human stylists. So this is what I mean by having humans in the loop. So we actually have humans making decisions in a production system about what's actually sent to the client. So the list of recommendations is then curated by our human stylists, who are actual StitchFix employees who are passionate about fashion and finding the right items for our clients. And it's this combination of both human curation, but then also algorithmic recommendations that really makes this work so well. And I think it's particularly important in a difficult to quantify field like fashion. So I mentioned I'll share 3 lessons. We're going to start with 1 bonus lesson for free though, and that's lesson 0, that humans and machines are a winning combination. So this combined system works really well. And there's a few reasons why this is the case. So one is that humans are really good at leveraging unstructured data. So we've heard from the previous speakers today, a lot of the most interesting and compelling information that we have about fashion and style is really unstructured. So either free-form text or images. And while there are algorithmic approaches for using this data, humans are just really good at it. And so we can leverage their just innate human ability to process unstructured data. Some examples from StitchFix would be the request note that clients give us when they sign up for a fix. So You can say, for example, I'm going to a wedding, please send me a formal dress, or I'm going on a vacation, please send me something for the beach. Using that text is something that you can treat algorithmically, but it's hard to do with really, really high confidence, whereas a human can easily read that and understand the intent of the client. Likewise, to share their style preferences with us, our clients have the ability to create a Pinterest board that they share, where they can pin images from across the internet that capture their style preferences. And here, so you have a very large set of images, which kind of holistically capture the type of items that our client might like. Once again, there's a lot of very interesting image processing and computer vision algorithms that you can use to understand this collection of images. There's also just a wonderful holistic human ability to look at those images and understand the intent of the client. Another thing that's very important for a company like StitchFix is developing relationships with our clients. And so by having a human in the loop, we actually can respond to requests, can learn from feedback, and develop an ongoing relationship with the clients. And that's something that would be hard to do without a human in the loop. And finally, an interesting one is that it really frees the algorithm developer from focusing on edge cases. So if we had an algorithm where whatever the top 5 results are, they just get put in a box and sent to the client, we'd have to spend a lot of time making sure that strange things didn't happen for outlier clients or outlier inventory. By having a human in the loop, they actually catch many of those things for us. And this enables us to think about the average case more than an outlier case. And this helps a lot in algorithm development. So the first lesson I wanted to mention is that by using this hybrid human-machine system, you actually have more than one feedback loop. So in a traditional recommender system, so think Netflix recommending movies or Pandora or Spotify recommending music, you make recommendations directly to the consumer. And so you make predictions about what they're going to like. You then get feedback you can use to improve your systems in the form of how they interacted with your recommendations. So at StitchFix, this is intermediated by the human stylist. So the process I described is we use algorithms to produce a set of recommendations, which are then curated by the human stylist and sent to the client. And it's only on that subset of things that are actually selected by the human stylist that we observe client feedback. And so this introduces another layer of feedback. So in particular, when we make recommendations, we can learn from how stylists interact with them. So if we're making a terrible recommendation for a yellow polka dotted dress, a stylist might say, oh, well, that's a bad choice for the client, and choose not to send it. If that happens systematically across many clients, we can use that information to improve our recommendation algorithms. There's more subtle implications of this layer of stylist selection, though. And this leads us to the second lesson, which is that human selection can change your objective functions when training models. So as a data scientist, when you first start thinking about a data problem, one of the first and perhaps most important questions you should ask yourself is, what am I actually trying to predict? How should I measure success? And when first presented with the StitchFix problem, you might say, I'd like to predict the probability that a client will keep something if we send it to them. If I could do that, I could say, this is a great dress for the client, or this is a scarf that she'll hate. And based on that, I could eliminate some items from consideration and really promote things I think will do quite well for her. And one source of information that we have that's this easy to get is our historical shipments to clients. So StitchFix has been around for a few years, and we have a lot of data delighting a lot of our clients in the past. And so we can go back to that historical data and use that as training data and try to build models for what people actually like. It'd be kind of the traditional supervised learning approach to the problem. The important thing to recognize here, though, is that we're actually making an approximation when we do this. And that approximation is that the probability that somebody likes something is the same as the probability that somebody likes something given that a stylist selected it. So remember, we only ever observe things that our stylists select for clients. And this is important because it can introduce some forms of selection bias into our data. And I'll talk about those in a little more detail. The advantage here, though, is if we just ignore that, we just say, let's forget that there's humans intermediating these recommendations and just train a model. Recommendations are a very well-studied field, and this becomes a kind of a traditional supervised machine learning problem. But there's some problems with this approach. And the first is that using human stylists, or humans in general, to make selections can introduce a form of censorship into your data. So consider the following example. One of the things we ask our clients when they sign up is whether they like to flaunt different parts of their body. And one of those questions is whether they'd like to flaunt their arms. And so a client could say no. And in that case, our stylist will probably not send them things that would flaunt their arms. And this is absolutely the right thing to do for the client. So the stylist is sending them things that are consistent with their preferences. But suppose that this was always the case, so that we were absolutely sure that we never violated this preference of a client. Again, it's the right thing to do for the client. However, when you go and look at your historical data, you'll find that you don't even have any data that demonstrates what happens when you violate that preference. So if you go to your historical shipment data and train a model, and you ask it, is it important to honor this preference, you'll find no support in the data that it is. And so you can censor some negative outcomes, which again is this interesting paradox where something wonderful for the client, but maybe tricky for the model developer. There's a similar problem from introducing this layer of selection that has to do with the difference between a probability that a client will like something and the probability that they'll like it, given that it was selected by one of our stylists. So if we built a model based on our historical data, so again, looking at things that were chosen by stylists to be sent to clients, and we, say we used a traditional recommender, and now we have good probabilities of whether that item would be kept by clients if chosen by a stylist, we could rank everything in our inventory by those probabilities. And intuitively, what we'd really like to say is that this is something akin to the probability that the stylist should choose this for the client. Because after all, what we're doing is making recommendations for our stylists to curate and then to make final decisions about what to send to our clients. But this is really quite different. What we're actually doing is really quite different from what you might hope. What we're actually ranking by those conditional probabilities is something much closer to the probability that the stylist will be able to send that item successfully. So it's really more of an error rate on human decisions than it is a fundamental probability that the client will actually like that item. And I'll illustrate that with an example. And it's a subtle but important difference between ranking by these conditional probabilities and ranking by the unconditional probabilities that we don't actually observe. So suppose we had an item that was very low coverage. And so what I mean by that is something that's great for some small subset of our client population, but inappropriate for most of our clients. So a good example of this would be something that's very edgy. And so let's suppose we had a very edgy dress, and when a stylist saw it, they'd immediately be able to say, oh, this is really appropriate for the client or not. Because it's a very polarizing item. It's really easy to make a decision successfully about whether that would be a good choice for the client. And so if we looked at the historical data, we'd find that, well, this is often sent to the right clients because the stylists are able to make a good decision about it because it's so clear whether it's appropriate for a client or not. So contrast that to a style that maybe is appropriate for most people, but the signal that indicates that it's a good choice for the client is much less salient. So it's just much less polarizing. And so if you ask a stylist, they might not know. Like, I don't know, like a lot of people would like this, but I don't really know if this particular client would like it. And if you looked at the historical success rate of sending that item to clients, what you'd find is that you might have a moderate success rate. And so you might then be tempted to conclude, looking at this historical data, that you'd be better served recommending the first edgier item than the latter one, even though we know that it's actually appropriate for a larger subset of our client population. And so what you could find yourself doing is recommending decisions that stylists can make successfully. But these are probably terrible recommendations. If you think about what a stylist is doing, they're taking information from a recommender system, they're trying to curate it, choose things that our clients will love. What we're showing them are decisions that they can make really easily. So they might be able to say, oh, this is a terrible choice for the client, and make that decision successfully, but it would make for really bad recommendations. So this is another more subtle problem with ignoring that feedback loop of stylist selection in the process that we use. So in both of these cases, making effective recommendations for our stylists requires understanding the process they use to select items. So in the first, we mentioned you might actually have censorship, where you just don't observe what happens for some cases that are censored by your stylist. If you looked at the data for their selection process, that is, if you looked at the items that they had to choose from, you might be able to build a model to say, oh, well, they seem to always choose from a particular subset. In this latter case, being able to get at those unconditional probabilities, so correcting for the conditioning on selection, also requires understanding the way that stylists make decisions. And this is understanding how humans make decisions about fashion, and in particular, how they make it in the context of this recommendation system. And so this is a fascinating area of work. It's usually a bit harder than the initial problem that I outlined. So selection data tends to be much larger. So the original data set conditioned on selection that I described is essentially our transaction history. So what have we sent the clients in the past? How have they liked it? Have they rated it as something that they'd want to keep? And that is, proportional to the number of shipments that we make. Selection data tends to be a bit larger. So understanding what was the set of things that the stylist could have sent, and how do they interact with that? And so this very quickly changes from a small to medium-sized data problem to a big data problem. And so it just gets, everything involved is a little bit heavier. It also becomes a bit more like some aspects of search engine design, where if we recommend something very often, it's probably more likely to be selected. If we were trying to predict selection, it'd probably be more likely to be recommended in the future. So you can get feedback loops unless you very carefully study presentation effects, which correct for the effect of how we actually present things to stylists in the first place. And so the conclusion of the second lesson is that the presence of human selection in this recommender system forces us to understand the probability that they'll select something, and that problem is in general a harder problem than just looking at transaction history. And so the last lesson I wanted to share is that even humans need feature selection. And so recall the way that StitchFix works. So we make these algorithmic predictions, and then humans take those results, our stylists take those results, and curate them and pick things for our clients. And you can think about this as just another layer of classifier. It happens to be that there's a human there making the decision, but if there was a smart enough robot, perhaps they could be included in the system too. And like any algorithm, you can think about feature selection. So our stylists have a lot of unstructured data. So I mentioned this is one of the principal advantages of using humans in a system like this in the first place. But this can be hard. So imagine if a client had shared a Pinterest board with dozens or hundreds of images on it. That's a lot of information that could be overwhelming to understand. So one thing that we might try to do is to derive some features from this that are useful for human decision making rather than algorithmic decision making. So for example, we could try to describe the types of styles and maybe project the things on the Pinterest board onto understood, well-known fashion dimensions. So things that are edgy or boho, romantic or casual. We could also try to do some sort of dimensionality reduction on the Pinterest board. So what are prototypical examples of things that have been pinned? And use this to help describe the content of that Pinterest board for one of our human stylists. And of course, which of these should we use? There's many possible algorithms that you could use to try to reduce the dimensionality of the data we have from our clients. And so we have this question of what's essentially feature selection. So we have feature 1 or feature 2. Which should we use? And in this context, use means make available to our stylists for them to make their decisions. And when presenting algorithmic results to humans, it's always important to focus on interpretability so that what we're showing actually is something that they can understand and make sense in the context of the decision that they're making. To also share evidence. So for example, a collaborative filtering type feature might say, she's likely to keep this dress because of this related blouse that she's kept in the past. And also orthogonality. So if we have a lot of features that are similar and the information content is redundant, it's not going to be helpful in an incremental way in helping our stylists make good decisions. And for fashion data especially, this is really hard. So this unstructured data, there's many different ways you could go about structuring it and trying to summarize it for human consumption. So what we do at StitchFix is to turn this into an empirical question. So stylists use a tool for making their decisions. And so we can run experiments with different versions of features or different types of information that we share with them and find out which are the best for actually making good decisions. So we can look at business outcomes, which type of information actually helps them make good decisions about what our clients actually want to keep. And we can also do this in a more simulation context where we can use historical data to evaluate how helpful different types of information are for stylists guessing whether something would have been kept historically by different clients. And so this is really interesting. So in addition to building machine learning models and doing kind of the usual supervised feature selection and model selection, we have this secondary stage where we want to do the same thing for the human classifier and explore the space of things could be put into that algorithm and optimize that set to ultimately optimize what gets sent to our clients. And so in conclusion, using humans in the loop in this manner is extremely effective, and especially in a domain like fashion, where there's so much unstructured data and there's so many different aspects of the problem that are difficult to quantify, having humans in the loop really makes the algorithms much more successful. There's a cost to that, however, and the cost is that the problem shifts from being a simple supervised problem to something that has many complicated feedback loops and relies, in part at least, on understanding how humans are making decisions about the data that you share with them. And it makes the problem much more complicated, but also much richer. And with that, I'd be happy to answer a couple questions.